Welcome to the Passion for Technology podcast. In this episode, we're diving into an article from our latest TQ magazine, exploring the fascinating world of human-machine interfaces. For more details, interesting insights, and valuable infographics, be sure to check out the show notes. A completely new universe. It's posited to be nothing less than the future of the internet, the Metaverse. At its heart, it's about a new, complex virtual world where one lives as a digital twin or avatar and may in the future also work and carry out daily activities. There are numerous connections with the real world. For example, virtual goods can be purchased with real money within the Metaverse. Behind avatars are real people, and behind virtual machines are real industrial complexes in the sense of a digital twin. The Metaverse is one of the most thrilling visions of our time, says Dr. Bernhard Rohleder, CEO of the German industry association Bitkom. The Metaverse is built upon technologies that are already well established, such as augmented and virtual reality, blockchain, or artificial intelligence. The representation of virtual three-dimensional spaces, objects, or individuals, and the ability to interact with them are increasingly being employed not only in entertainment, marketing, and e-commerce, but also being tested and applied in industry, education, and services. What has long been familiar to computer gamers is now being discovered as potential across various industries. A core element of the Metaverse is the potential for realistic interaction in real time between different users or between users and machines. The immense advancements in hardware, both at the infrastructure level and in human-machine interfaces, have been prerequisites for the growing acceptance of this new virtual world. The major software companies are now entering the market with their hardware solutions. Meta purchased the VR headset developer Oculus in 2014 and now sells its own headsets under the name Quest 2. Apple has filed several patents over the last decade and launched their Apple Vision Pro in July 2024. Current systems also use controllers that enable targeted touches with virtual objects through finger, hand, and arm movements. On the infrastructure side, faster fiber optic networks and the introduction of 5G are reducing the effects of latency times and increasing available bandwidth. Today, serious applications in industrial environments are possible. For example, Aegis, a manufacturer of energy chains and plastic glide and linear bearings, has created its own virtual world where users from around the world can interact and collaborate on projects without the need for physical presence. Automation solutions can be planned, controlled, and tested in virtual space using extended reality technologies like virtual reality and augmented reality. In the future, we will see how collaborative work between humans in the Metaverse and, for instance, the control of robots from virtual worlds will change the way we work together, says Marco Thol, senior marketing activist at Aegis. In the future, the virtual world may even become literally tangible. Jürgen Steimle, a computer science professor at Saarland University, aims to achieve this through ultra-thin electronic films that can be applied to the body like transfer tattoos. Most applications of augmented reality have one thing in common. They only or primarily address the sense of sight. The sense of touch is usually left out, although it's a crucial factor in how we perceive our world, explains Jürgen Steimle, who leads the research group on human-computer interaction at Saarland University. Steimle's team has developed an ultra-thin, only 35 micrometers thick electronic film in the project TAC2, which can be applied to the skin and stimulate the sense of touch solely through electrical stimuli without any moving parts. Because the film is so thin, objects can still be perceived and felt as before. Not only can haptic experiences for purely digital objects be created, as already possible with other solutions, but real objects can also be extended with other sensory impressions. For example, the technology could be used in product design. With the help of augmented reality and a physical prototype, the haptics of different materials could be tried out. For the Metaverse to find broad application, a range of technologies for collaborative spatial data processing must be integrated, from interactive 3D graphics to physical simulations to the online economy. The Metaverse's potential will only be unlocked if it is built on a foundation of open standards. To this end, the Metaverse Standards Forum was established in 2023, a nonprofit consortium that doesn't want to develop its own standards but brings together various metaverse stakeholders to create consensus on interoperability requirements. Interoperability is the key to the metaverse scaling to its full potential beyond siloed games, experiences and worlds, and the unprecedented level of participation in the forum demonstrates strong industry interest in the broad cooperation necessary to bring that vision to life, says Neil Trevitt, president of the Kronos Group and initial president of the Metaverse Standards Forum. We hope you enjoyed this episode. For more in-depth information on the latest trends and technologies in human-machine interfaces, check the show notes to access the latest TQ magazine, available free of charge.